This is a quick overview of TinkerCAD. It's a free online 3D design program. Online in that it doesn't require any installation on your computer, so it doesn't matter Mac or Windows. You simply interact with it through your web browser and free for your accounts. TinkerCAD is now owned by Autodesk, a company who has an almost monopoly on 3D design and CAD, computer assisted drafting and design. They have lots of software that is available free. And so if you go to tinkercad.com and look, let's see, near the bottom, you'll see some of their other applications that are free. On the left-hand side, under the 123D apps, these are all the ones that they have either bought or created that are freely available. Meshmixer is a great tool. It does require installation on your computer, but it's a great way for taking existing very complex designs and then mashing them up, or that is mixing them together and being able to do things with them. And then 123D are a set of applications that are available typically on desktops as well as on mobile devices. 123D Catch, for example, allows your smartphone to take pictures all the way around a physical object to create a 3D object in virtual reality. And then you can put it into 3D design software or get it 3D printed. So if we go back to the very top, even right now, the end of June 2016 at least, there is a challenge, a contest, if you will, for creating objects with ball joint connectors. So I'll quit out of that for now. Click on the menu button and you can sign up for an account, and if you do, you need to put in your country, your birth date and whatnot, your email address, and it'll allow you to create an account. I already have one. In fact, I have an Autodesk account, which is a very nice tool for those of you who would be very interested in forms of 3D design. Autodesk has a great program for educators and students, such that if you create an Autodesk ID account, you'll have access to all of their design software free. So I have one of those accounts, so I can just put in my information and sign in. But again, you can create just a simple free TinkerCAD account if you choose. I'll say yes, remember me. And since I am logging in with an existing account, you can see what I already have created. So I have lots of little designs that are here on the lower right side. Excuse me for the size of this recording. The web browser is kind of small because I chose to make this 720p video, so I didn't want to make it larger than that, so it'd be more accessible for people. So you can have your individual designs here, but also you can create projects. And so a project can have multiple designs in the project. This is nice if you're going to have lots of pieces sort of in a collection. Think of a project like a collection. But you can very quickly just go ahead and get started by clicking on the Create New Design and go forth. So they give you an arbitrary name for your object. You can, of course, change that if you want, but that's what they give you. Within the program, there's very few menuing options at the top. Under design, think of that kind of like the file command in like Microsoft Office and other kind of applications. This is where you can create new objects and save things, and also you can download and export, that is, share your designs. Saving is automatic, but we do recommend that you click on the design save when you're done with your object. And then editing, you have very few options. It's kind of like cut, copy, paste, deleting, duplicating kinds of features. Help is a good one. You can go to a TinkerCAD tutorial video, which I'm guessing is better than the one that I'm giving you. YouTube is your friend. There are lots of TinkerCAD videos and information available on the web. Okay, as far as the interface itself goes, your main workspace is on the left-hand side. You can navigate it using Google Maps or Google Earth type navigation. Home button recenters your home and gives it this perspective that we're currently looking at. You can, of course, increase and decrease your tilt and rotate your object using those buttons, and you can zoom in and out that way. Um, so those are fine features. I'll tell you, it's a lot easier to work around by using a mouse or trackpad. You'll need to really play with it a little bit yourself to get used to it. But I'll give you a couple hints about how to use a mouse at least for working with it. So if you have something like an Apple Magic Mouse, you treat it a little bit like a scroll wheel on a two-button scroll type mouse. Your scrolling bar or Magic Mouse sliding up and down allows you to zoom in and zoom out of your work plane. And then most of your other manipulation is done with the right click and drag. So the reason why is they leave the left click and drag for being able to select multiple parts. So think of this a little bit if you've ever used something like PowerPoint where you're able to click and drag around your slide and be able to select multiple objects that you might have within your design. Think of it like that. So for navigating, you do right click and drag. So I'm going to right click and drag, and I can alter the angle that I'm looking at the work plane. Okay. Now, if I want to hold down the Shift key and right click and drag, I have to make sure I right click and drag, I can now pan around the work plane. So the three features: zooming using the scroll wheel, right clicking and dragging to alter the angle, and shift right clicking and dragging to move around, allows you to navigate all around your work plane. Okay, next thing up is your grid. So Snap Grid is set for 1 for the default. I would probably leave it there. You can click on Edit Grid, and you might want to edit this depending upon what your 3D design and printing application is. Millimeters are the default. Hopefully you're comfortable with metric, because a lot of 3D printing and manufacturing, fabricating equipment uses metric and uses millimeters specifically. It's typically set by default for 200 by 200 height and width millimeters, because that's the largest common plastic type 3D printer that's out there. So about 8 inches by 8 inches. But you can, of course, change that or make your own. I'll hit cancel and not change it at all. Now in the upper right, you have some shortcuts to some of the sections that I'll be describing here. But in general, you have a column on the right side that is highly scrollable across lots and lots of different sections. So let's get going. You can, of course, import objects. So if you have a 3D design or even a 2D shape, there are a lot of compatibilities. I don't really have the time to go through all of the compatibilities. You probably want to go to the TinkerCAD help information if you're concerned about whether it's going to be able to open your file type that you might have already available. Or you can just try it and see what happens. So you can import a design into your existing work plane that way. Further down, you have shape generators. These are typically features that when you use that, like polygon, for example, it takes you through a wizard of lots of different parameters for that object. So I'm going to click on polygon, for example, and I place it somewhere by clicking again, and you'll see this wizard appear. You can alter the color, for example, let's say light blue, sort of aquamarine. You can also make it whole, which I'll describe later, and you can lock that transformation. You can, of course, alter the number of sides. So it starts with 5, but you can make it like an octagon. You can choose how the size is specified. Right now it's set for 20 millimeters. You can, of course, change that, but is that 20 millimeters the radius or length of an apothem or length of a side? You can, of course, alter the height however you want. So, see that. And, of course, whether it's actually pointed or not. So when you click off of your object, you'll lose that wizard. And, of course, if you click the object again, that wizard will appear. Hopefully, you're able to use a monitor with much higher resolution than this recording that I'm making, so this wizard will not be crowding your object in your work plane. There's, of course, other features that you can do to edit your object. So just play around with them, basically. If you have your object selected, you'll see these curved arrows, and when you move your mouse over them, you'll see a protractor or compass type tool appear. And so if I click and drag, it'll allow me to rotate the object. If I'm moving my mouse pointer along the inner ring of this protractor, it's going to be moving in very well-defined large angle changes. So you can move, rotate things like on the 90 degree or 45 or half of 45, which is 22.5 degrees. If you move out to the outer ring as you're rotating, you can now rotate by single degree angles. Okay, so that's how you can rotate. You can scale things by, if you want to scale the entire base, you can click on a corner, for example, and drag it. This is kind of like PowerPoint or some other tools you might be familiar with. Of course, if you just click and drag around, you can squeeze or expand it. But if you hold down the Shift key while you're doing it, it now forces the two dimensions, height and width, to remain locked. So it keeps it being a square object as you increase it. And watch what happens if I let go of the Shift key again. It then allows me to alter it like I had been. So let's say you can shift it, pick a size, and stop. You can change the height of it by moving to the apex of that cone and raise and lower it. You'll see what the final height is on the right hand side. They show you dimensioning at all times to really help you out. You can of course raise and lower this by default. Whenever you create an object, it's going to put the base of that object on the base of the work plane, but you could raise it up into the air, for example. While you have your object selected, go find that arrow that is above the object, centered on it, and click and drag. And it'll show you the distance that it's moving up or down. Down is negative, and then up in the air, for example. Right now, if I stop right now, it'll put it 14 millimeters up in the air. Okay. I can click on the object, and I can go to edit and delete if I don't want it. For example, so I'll show you some of those changes. So those are the shape generators. So there's a bunch of them here. Text is a real nice one. You can add 3D text. If you're 3D printing something, I would suggest that you put the 3D text onto like a single object, so like a bar or a plate, so they all print as one object. Otherwise, you're going to have lots, each letter will be its own 3D printed object, and that might be difficult for you depending upon what your outcome is. You can, of course, change the size of your text, and, of course, what is the text itself. So I can say 3D design, okay. I might want to have more space between the D's, so you can, of course, add more space. It's not going to say that's a misspelling. It'll let you do things like that. So there's text for you. Then further down, there's other kinds of shapes, generator shapes. Components. This is the contest that's running right now as of late June, where you can create one object that uses, let's say, one kind of connector, and another object that uses another connector. Next section is geometric. These are the simple shapes kind of thing, like you might have in word art. So you click and you can drag your object, you can pick the color, you can make it into a hole. You can, just like before, I talked about all the different ways you can alter the size of it. So I'm going to show you an example of what is a hole. So I created a red rectangular prism, and let's just say I want to have a hole in it the shape of a cylinder. So I want a round hole. So I click and drag it over. It's also going to put it at the same level because the work plane automatically decides it. And when I have it clicked and selected, I can change it into a hole. Now if I have it as a hole and I 3D print this, it's going to make a rectangular prism with a vertical hole in it, the size that I had determined, which was, I just left it the default. You don't actually see it as a hole right now. You see it as these diagonal stripes. I'm not sure if I can zoom in well for that, so hopefully you can see that. Maybe that's a little bit better. But trust me, if you 3D print this, it'll print it as a rectangular prism with a vertical hole in it. So you can make other shapes, like I can take a pyramid and make a pyramid, and then I can raise it up, for example, and I can place it. Let's say make it like really small. Um, let's see how I have it there, and I can make it, and I can put it so it's right on top of the box. And so if I 3D printed this right now, it would look like a box with a hole in it and a small pyramid on top of it. And that would be a single object that gets 3D printed. Of course, I can change the color, so I can click on color and make this red as well. So everything is red. So there's a lot of things that you can do by just adding these objects. Because all of these are well-defined geometries and you're adding them to well-defined geometries, TinkerCAD's advantage is that you're guaranteed that whatever you design is theoretically 3D printable, meaning that at least mathematically there aren't any gaps or problems in your object. There's still design best practices about making something that is 3D printable. They typically suggest like you shouldn't have this spire be too narrow, for example, or it's going to be very weak when 3D printed. There's lots of best practices that I don't have time at the moment to go into. But just think about those kinds of things. Let's see. Oh, by the way, you can undo. I just did it now and I forgot about it. So if you're on a Mac, sort of Command Z, or on PC, Control Z, but those keys will allow you to undo things. So even undo is capable in TinkerCAD. What we didn't really talk about specifically what you can do to export and make use of your design. So of course you want to save it when you're done, and it has been saving the whole time, but it's nice to be able to see all changes saved once in a while. You can download the file for 3D printing if you have your own 3D printer or access to one. If you don't care about the color of it, or the 3D printer doesn't have multiple color compatibility as one of its features, you can download it as an STL file or an OBJ file. STL is probably the most common file format. You'll want to remember whatever units you used in TinkerCAD, for example, millimeters, because STL and OBJ don't necessarily contain that information. So when you import it into the software for 3D printing, it's going to ask you, what were the units? Were they millimeters, inches? And of course, that'll have huge impact on the size of your object when 3D printed. So, select the file format and remember what units you used. If you want the file to be able to contain the color information that you had used within TinkerCAD, you'll want to download it in X3D and or VRML file format. So let's just say I'll select VRML file. Your web browser will start downloading the file. That's ways you can download for your own 3D printer. You can also download to Minecraft. You have to pick how you want your design to get pixelated into Minecraft's world. So how many millimeters in TinkerCAD should be converted to one Minecraft block. You select that and export it, and when you do, it'll download a schematic file. There's also ordering a 3D print. So if you don't have access to a 3D printer and or you want a quality that is different than the capabilities of your 3D printer, you can click on Order a 3D print, and they show 5 of the top 3D printing services that are out there on the web. I recommend, if you want the most professional type output, that you stick with iMaterialize or Shapeways or even Sculpteo. So if you click on one, for example, you can say I want it 3D, let's say print the 3D colors. Click it. It'll, if you've never done it before, it'll ask you to authorize the connection between TinkerCAD and Shapeways. Unfortunately, I've already done it, so it takes me right into my Shapeways account. If you don't have a Shapeways account, even with the authorization, it'll then ask you to create an account at Shapeways. The reason I'm doing this is because I want you to be able to see what Shapeways would do with it. So you have your object in Shapeways. You can, of course, kind of roughly look at the design, make sure that you didn't export the wrong shape or anything like that into Shapeways. It'll show you by default what is the size of your object based upon what you use in TinkerCAD. Right now it's showing for me that it's going to try to print it in 66 cubic centimeters. The surface area is how much surface is exposed. That is kind of like the ratio between the material volume and the surface area, and that all gets at the price of the object when printing. For example, if you're using a 3D printing technique that involves color, then the amount of surface area is going to really matter. So you can of course scale it up and down if for some reason you did not design it at the right size and scale in TinkerCAD. You can increase or reduce it, or if you're just you designed it the right size, but you don't want to pay the prices for large scale 3D printing, you can scale it down to the point where you want it printed. You then have lots of options for 3D printing, and the sections are all here with shortcuts to them. In general, you can say I want to print, let's say, in metallic plastic. Means that it actually is printing plastic, but it'll look metallic and will have some of the characteristics of metal, kind of density and things like that. Whereas sandstone. So sandstone is an interesting one. They call it sandstone because it'll have a very textured surface when printed, but the important thing about sandstone is that that's the only one that I know of where it'll contain the full 3D coloring information that you have if you so choose to print it that way. So right now, if I take my design with the rectangular prism, hole, and pyramid, and I print it at the size that I designed it, and I wanted it full color sandstone, it would cost about $52 to print. However, I strongly recommend that if you wanted to do such a thing, you actually print it with a coated full color sandstone. Coated is not just that it puts like a sealant on it. The coated also brings out the colors much more vividly and makes the object much stronger and less brittle. So I would recommend coated full color sandstone. So that'd be $64. So for example, if you wanted in stainless steel, click on stainless steel, and the price is going to be about $336. So some people use TinkerCAD for designing jewelry, and then they have it 3D printed for them. Shapeways is just one of them. I'm not particularly endorsing them, but I have used them before without any trouble. I think I said it before, but Google and YouTube are your friends. There are lots of sources for TinkerCAD tutorials and videos. So I hope you have fun 3D designing and would be interested in knowing what you would want to make. Take care.